Hi. So far we discussed about what is static route and what is dynamic route, right? And next one that we have is that is dynamic routing. Okay. So before going to the dynamic routing, okay, we need to aware that like what is administrative distance. Okay. So administrative distance is nothing but like it's a trustworthiness of information received by the router. Okay. So like so we have one router and we have another router. Okay. So how much trust we can like reach the other router. Okay. So the trustworthiness receive information received by the other router is called administrative distance. Okay. So this administrative distance is the value between 0 to 255 to 255. Okay. So the more value, the less like trusted I can say. So the less value, more trusted. Okay.
What
Yeah. So like it's in no like inverse way. Like less value, more trusted.
What trust?
More value, less trusted it is. Okay.
Less trust.
So here like we have some things that we can if it is directly connected. Okay. Suppose you have a router. Okay. And you have another router. Okay. Suppose which is directly connected means their AD value is 0. It means it's a more trusted network. Okay. Suppose there is a like other network which is pointing route in the static route is configured. Okay. So that is called like I mean when we perform static route for the subnet. Okay. So for that routing or like the network, the AD value is 1. Okay. So we have 0 for directly connected network, and whatever the network which is having the static route in place, this is for 1. Okay. So these are like some of the dynamic routing protocols. Okay. So we'll discuss about the dynamic routing
Okay.
protocols. Okay. So we have like many default route also we have, right? So default route also we have the least value is for default route. Okay.
Okay.
So we have many routes, that is static route,
Dynamic
dynamic
default.
default is there, right? So first,
Okay.
first one is directly connected. Directly connected will be first preferred, then static route, then dynamic, then default. Okay,
Okay.
this is about like a AD value. So suppose if we have two routes are configured. Okay, so we have static route and we have some dynamic route also which is configured with the protocols. Okay, so at the point of time,
Okay.
it will prefer to take static route only because it is more trusted one if we compare with others. Okay, that's about
Yeah,
AD
okay.
value. So when it comes to dynamic routing, okay, so in case of static routing, what we are doing, so we are configuring routes wherever it is connected to it, right, on the specific router. Okay, so but in case of dynamic routing, what happens? No need to configure all the like suppose this is a router. There are many networks which are connected to that, right? Like this, all these things. So what we were doing, we are pointing, we are configuring the route to all the other routers, right, which are connected to that in the static route. But in case of dynamic
Yeah.
routing, what happened? Okay, we won't configure route to all the other connected subnets. Okay, we will just add the network. Okay, to the router where it is connected to. Okay, and
Okay.
remaining every other networks, it will listen. Okay, so like neighboring routers exchange the routing information and build the routing table automatically. So suppose we have another router, this is another router. Okay, so in general, what we have to do, we have to point out the route towards this IP address, right? But in case of dynamic routing, we won't configure any routes here. Okay, we will just configure in this router R1 saying that this is your connected network. Okay, so remaining whatever the things is there, it will be go with the dynamic routing protocol. So by using this dynamic routing protocol, what it does, it will learn all the routes which are connected to it. That is these routers, all these things. Okay. So by this, what happens, like administrative work is reduced. Okay. How administrative work is reducing here? Suppose we have, like suppose 10 routers are there. Okay. So 10 routers are there. Okay. So what we are
Okay.
doing earlier in the static route, we were if any new network is adding, so we have to configure the route for the new network in all the routing tables, right? In the other
Yeah,
routers.
yes.
But in case of dynamic routing, what we are doing, we are just configuring the network what it is connected to. And Then what this router is doing? This router is capable of like learning the routes from the neighboring routers automatically. Okay, so how it is getting the routes automatically means by using dynamic routing protocols. Okay, so if any new
Okay.
network is happening, so what we can do? We can just add the router and we can configure whatever the network is connected to it. So if you want to reach from here to here, it will be get the path automatically. Okay.
Okay.
So like this is dynamic routing protocol used for larger networks. That's we are aware. Okay. So here like no need to aware of the destination networks, because here we are just configuring only the connected network only, directly connected network only. Okay. So others we are not configuring here. And
Okay.
yeah, and we need to advertise the directory networks only. That is also done. Okay. So updates in the topology. So from where to where it has to reach. Okay. Suppose we have two
Okay.
ways. Okay. Way. Okay. So we have two ways to reach router 1, 3, 2, 3, 4. Okay. So to reach router 3, we have two ways, right? 1, 2,
Yeah.
3. Two ways are there. This is one, this is one. Okay. So usually it has to connect to this one only. Okay. But for some issue, for some reason, the link has been failed. Okay. Then this dynamic routing protocol has the capability to share the information through R2 and R3.
1, 2, or 3.
Okay. So that is called, like a topology thing is dynamically. Okay. So it is easier
Okay.
than static routing and default routing, because we are just configuring the route which are connected to it. Okay. And if you want to configure the static route, we need to aware what and all the destination we need to reach. Okay.
Yes.
So that's why it is easier to configure. This is a small brief about dynamic routing.
Dynamic.
Okay.
Okay.
So we have like two types of dynamic routing protocols. One is interior gateway routing protocols and exterior gateway protocols. Okay. So the name itself it is defining here. Interior means inside network.
Internally.
Inside network. Internally we can say. Exterior means out of network, outside of network. Okay. Suppose this is an organization. Okay. So in the internal, we will be having n number of routers, everything, right? So in internal organization, we'll use internal gateway routing protocols. And suppose we have like one more company that is using IGP, internal routing protocol they're using inside organization. Okay,
Okay.
inside organization. So now these two organizations want to communicate with each other, then they need to configure with
External gateway
EGPs.
protocol.
Okay, is it clear? Inside
Yes.
IGP, outside or between the IGPs, we'll go with EGP, that is exterior gateway protocols. Okay, so let's go further. So here, like autonomous system, like there is one terminology called autonomous system. Autonomous system is nothing but it's a collection of networks that are managed under a single organization. Okay, so how many? So inside organization we are using IGP, right? So
Yes.
inside organization will be having like autonomous systems. Okay, so it's under single entity. I'll show you one diagram is there. Okay, so if we can see here. Okay, so in this is one inside organization A. This is B, C, D. Okay, so inside organization, the system everything is called as one autonomous system. Okay,
Okay.
inside organization is called autonomous system, and so here like inside we'll be having a number of in one number in what one autonomous system will be having n number of routers. Okay, so to make communication possible between inside autonomous system, we'll go with internal IGP.
IGP.
Okay,
Internal gateway protocol.
yeah. So here between the autonomous systems, we'll go with EGP.
Between EGP.
BGP, I'll tell you like what BGP is nothing but border gateway protocol. This is the type of EGP. Okay, is it clear? So autonomous system in the sense like
Yes.
inside organization. So inside organization between the routers will configure IGP, and between the autonomous system will go with BGP. Okay, this is what it is. And we were discussing right interior gateway protocol and exterior gateway protocol. Interior gateway protocol is a routing protocol that is used to exchange the routing information within the autonomous system. It means within an organization, something like that it is. Okay. and Exchange Gateway Protocol, between the autonomous systems, I can say, between autonomous system. Okay. And so we have, again, this is the main categories actually. One is IGP and EGPs, and based on the classes, which class they are using. We have classful and classless, right? Okay, classful
Yes.
is nothing but suppose we have /24 network. We have to divide this into /27, /27, all the same numbers, right? That is for classful. Okay,
Yes.
classless is nothing but suppose we have /24. It can be divided into /25, /27, /28, according to our requirement, right?
Yes.
So here classful protocol, supports only I can say same kind of subnet it should be available. Okay, and this is what you need to remember. Okay, all the devices in the network must be in the same subnet mask. Okay, this means same subnet it is. Okay, so these are some routing protocols which you use, classful, I can say classful protocols are RIP version 1 and IGRP. We'll discuss about in detail what is IGRP, what is RIP version 1. But for now, what is classful protocol? It uses same subnet in the organization. Okay, but in case of classless, okay, so classless it is. Classless routing protocols carry subnet mask information along with the updates. Okay, so it means that uh, so we can use a number of subnets as per our requirement. Okay, so these are different types of protocols available. Okay, so let's discuss about one by one. Okay, so here so based on some other thing. Okay, so distance vector protocol, link state protocol, hybrid protocol. So again same thing it is. Okay, so RIP version 1 and IGRP is there. So this is some algorithm how they are exchanging the routes. Okay, so for link state protocol this is some algorithm. Okay, and hybrid protocol, this is the dual algorithm which is just. Okay, so it's not that important to aware of all these things, but we need to know what is RIP version, how it is exchanging the routes. Okay, so
Okay.
let's discuss about that. So we're discussing about IGP and EGP, right? So IGP is nothing but interior gateway routing protocol that are used to inside organization in the network. Okay, so that are limited to a autonomous system. That means inside organization only.
Inside the organization.
Okay, so we have protocols such as RIP, that is routing information protocol, routing interior gateway routing protocol, enhanced interior gateway routing protocol, and open status path first. Okay, so these are the four routing protocols which are available to configure the routings in the inside organization. Okay, so this we have some configuration, right? Distance vector, link state protocol, hybrid protocol. So here IRIP and IGRP comes under distance vector routing protocol. So we can say these two follow one kind of algorithm to exchange the routes. Okay, so OSPF and EIGRP, this follows some kind of algorithms. Okay, and when it comes to exterior, so it is to connect between the different autonomous systems. Okay, so we have BGP available. For BGP is nothing but border gateway protocol. Okay, this is about IGP and BGP, EGP. So let's discuss about one by one. So this is the same classification, what we discussed earlier. And when it comes to dynamic routing protocols, okay, so we have starting is RIP version 1. Okay, so RIP stands for routing information protocol version 1. Okay, it is classful routing protocol. It means if you are configuring RIP version 1 in autonomous system. Okay, so what is the requirement? We need to have all same kind of subnets. Okay, so that is about and updates between the routers will run through a broadcast. Okay, and we discussed about AD value, right? So for static route, it is 1, and default route, like direct line route is 0, right? Like that it is there, right? So if you configure RIP version 1 in the router, okay. So if you're configuring the route, what we do, we have to configure the network which is directly connected. and we have to configure the dynamic routing protocol, that is RIP version 1. Okay. So here between the routers, the route exchange will happen between the broadcast IP address. Okay. And the limitation here of RIP version 1 is it supports only 15 hubs. Okay. Suppose we have one router, this source is connected to this router, okay, and destination is connected to some other router. Okay. So between A to B, source and destination, it supports only 15 devices.
15
Router,
yeah,
router
okay.
2, router 3. It means like total 16 routers it is. But 15 hub count is nothing but a path. In the path it will go right. 0. So
okay.
it will go now. That is called like hub count. So it supports only 15. Okay.
Okay.
And here the drawback, what's the drawback? It's supporting only classful routing protocol. Classful routing in the sense all should be same subnets.
All, yeah.
Also, but in the practical scenarios, we are wasting the IP addresses, right?
Yes.
So that's why we have one more routing protocol coming to the picture, that is RIP version 2. Okay. So like what is the drawback of RIP version 1?
It is a classful.
Classful. So that's why we have RIP version 2 coming to the picture. This is classless network routing protocol. So here by using this network, we can use /27, /28, whatever the subnet according to our requirement. Okay, and it was introduced in 1993. Okay, so here the updates are RIP version 1 updates are through broadcast between the routers, and here in case of RIP version 2 it is through multicast. Okay, and here the thing is that so we are overcoming from the classful to classless network in the RIP version 2. But however, the hub count between source and destination, it should be 15 only.
Okay.
So in general, it is like 15 routers is very small. It is actually okay. So it is used for smaller organizations. Okay. So in some organizations, we'll be having hundreds of routers also between the source and destination. Okay, not 100 like it is, like it will be more than around more than 15, I can say, in general. So that's why, so if you have 15 plus routers, is RIP version 2 is capable of exchanging the routes? No, right?
No.
Okay, so that's why we have one more protocol coming into the picture, that is EIGRP. Okay.
Okay.
So and one more thing what we need to remember here, okay, while configuring the dynamic routing protocol in the router, we need to specify which version we are running, whether version 1 or version 2. Okay, so if you are running version 1, it should be classful network.
Classful network.
If you are running version 2, it should be like any network. So mostly version 2 will be used. Okay. And we're discussing, right, like between the source and destination, like only 15 hubs, it is possible. Okay, either RIP version 1 or version 2, only 15 hubs only. Okay, so because of that, we have the scalability issues. Okay, so that's why we have one more routing protocol coming to play, that is EIGRP. We'll discuss about that. And nowadays, still some people are using RIP version 1, version 2 only. Okay, because of some dependencies, some older networks or something, they are using RIP version 2 only. That should be fine if they are okay with that. Okay.
Yeah, okay.
So we have EIGRP. So what is the RIP version 1? 1 second.
Classful.
RIPV1 classful. That's why we have RIPV2. It is classless. But however 15 hub count only. So that's why we have EIGRP. Okay. So here EIGRP is a Cisco proprietary protocol. So it is developed by Cisco.
Okay.
Okay. So it is developed by Cisco. And here, the administrative distance is there now. So
yeah,
I can say the maximum hub count is there, right? So here the maximum hub count is by default 100 hub count it is. Okay, but we have the capability to till update to 55. Okay. So updates through multicast IP addresses. Okay. That is about EIGRP. So here In EIGRP, while configuring, we'll be having, n number of things, how they are configuring the routes and all. We'll discuss about that. Okay. So EIGRP works in 3 steps. Okay. One is step 1, discover the neighbor router. Okay. Step 2 is build relationship with the neighbor router and share the network path. Okay. So
Okay.
here, if you read this, EIGRP router joins the network and send the hello messages to discover the potential neighboring EIGRP routers. Okay. It means that suppose in an organization if you are configuring EIGRP in this router. Okay. So if you want to traffic, it has to go through like this. Okay. Suppose. So it has to
Okay.
know, it should know what is this neighbor router, right? So it will discover first what and all the routers which are
Okay.
connected to it. Okay. So what we are doing in the router, we are configuring the directly connected network. Okay. And we are configuring the dynamic routing protocol. After configuring the dynamic routing protocol, what this router does, it will just search for the neighboring routers. It means discovering the neighboring routers. Okay.
Okay.
So then what it will do after discovering, it will build a relationship with the neighbor. Okay.
Okay.
So to share the routing information. Okay.
Okay.
So to discover and to build the relationships. Okay. So it will send some hello messages and reply messages. Okay. It contains all the parameters to become a neighbor. Okay. So there should be some parameters required to become a neighbor of these routers. Okay.
Okay.
So that's about step 1. Step 2, what's happening? It is building the relationship with the neighbors. Okay. And step 3, it is sharing the network path. Okay.
Okay.
So there is some terminology. Okay, we are telling EIGP neighbor, we are telling, right? So neighbor in the sense the router which is connected to the other router. Okay. So EIGP neighbor is another EIGRP running router. Okay. Suppose you configured EIGRP routing here. Okay. So neighbor in the sense this is one more EIGRP router where EIGRP is configured. Okay.
Okay.
So this is called EIGP neighbor. So suppose we are configuring EIGP configuration here, EIGRP. Okay. So it has to find out the neighbor, right? Okay. So this neighbor is nothing but the other router where EIGRP is configured. That's it. That is called EIGRP neighbor. And update message is nothing but it sends the topology information. Okay. So routing information it will send in the update message. And in the query message, what happened? It validates the routing information. Okay. And we have 3 kinds of messages. I mean to say update message, query message, and reply message. Okay. So in update message, it is sending the topology information to the other router, saying that I'm having, this subnet is configured to me, something like that. Okay. And in case of reply message, what happens? It responds to a query message saying that routing information is valid or not. Okay. And we have the neighboring table. Neighboring table is nothing but what and all the routers which are connected to it. Okay. Suppose we have a router. Okay. And we need to aware of all the routers which are connected to this router, right? Okay. So in the neighboring table, it will consist of the information about all the neighbors, what and all it is connected to.
Okay.
And we have topology table. Topology table is nothing but it's a routing table. Okay.
Okay.
And successor, feasible successor routing table. Okay. So here successor is nothing but best path to reach the destination. Okay. And feasible successor nothing but if this successor or best path will be failed. Okay. Then we need to have other path, right? Suppose we have R1, R2. This one way is there. This is one way. Okay. We were discussing, right? If this is failed. So here, what is the best path? This is successor is the best path. This is the best path, right? And feasible successor is nothing but the backup. What is the backup for this one? Nothing is there. If it is down, then this is the feasible successor backup path. Okay. Just the words, it is what we need to remember. Okay. Only this is not our expertise to know in detail about all these things, but this is some terminology what we need to be aware of.
Okay.
Okay. Okay, and routing table is nothing but all the successor paths. Okay, so success is the best path, right? So whatever the best path
Yeah.
it will found, it will save in the routing table. Okay,
Okay.
so these are some of the components in the routing EIGRP. Okay, so here as we discussed, the RIP version 2, the drawback is it is supporting only 15 rounds, but when it comes to EIGRP, it is working pretty good. Okay, but
Yeah.
however, what's happening here? As it is developed by Cisco, it is supporting for only Cisco routers. Okay,
Okay.
but we are having a number of routers in the market, right? Like Juniper, many things are there. Okay, so that's why it is limited to only Cisco. Okay, so that's why
Okay.
we have one more routing protocol coming to the picture, that is OSPF, Open
Okay.
Shortlist Path First. Okay, we'll discuss about that. Okay, so here the pros of EIGRP is it is easy to configure. Okay, and convergence time between the routers is 200 milliseconds. That is also fine, but most advantage is stability. Reduces the router. It means that we can configure to a number of routers, and it is easy to configure. I can say in a simple way. Okay,
Okay.
but the cons is nothing but it's the disadvantages. Okay, so disadvantage is it is available for only Cisco network devices.
Okay.
Okay, that is about and it is a kind of distance vector routing protocol. It relates on routers provided by the neighbors. Okay, so how it will suppose we have the router. Okay, so whatever the route it is providing, it will be pushed to it, so R1 R2 is there. Okay, so here if you configuring EIGRP in router 1, okay, then it should be aware of some routes, right? So whatever the routes it is router 2 is sharing, it is dependable on another routers. Okay, that is one of the disadvantages of EIGRP. Suppose we were
Okay.
discussing, right? Uh, Successor and feasible successor, all these things. Okay, successor is nothing but only one path to destination. That is the best path. Okay, so if
Okay.
you have only one path, that is the only successor. If you have multiple paths to reach one destination, okay, so that is called successor, and backup path is called feasible successor.
Feasible successor.
Okay, that is about EIGRP. So these are some
These are
commands,
the port numbers.
not the port numbers. Okay, there is some metric is nothing but like the distance we can say. The distance between source and destination. Okay, so if you have less
Okay.
matrix, then it will be successor. This is
Okay.
the best path. So this is a feasible successor, right? Again, this is one more path. It is to reach the destination. That's it.
Okay.
Based on the distance, it will calculate. I can say, like best path towards the best path, it will go, right? Okay. So first best path is having the less metric value.
Okay.
Okay. So that is about EIGRP. So these are some commands. We need to check what is the route configured for some IP address in the router. Show IP route. And if you want to see, only EIGRP routes configured. Okay, so show IP route EIGRP, and if you want to see all the routers, okay, so which are connected to the router where we logged in, that is we can use a command called show IP EIGRP neighbors, and we can use one more command called show IP EIGRP topology. It will show the all EIGRP topology table. This is about EIGRP. Is it clear? So there is some commands, like what we need to remember to verify according to our requirements. Okay. See, you
Okay.
go through once again so that you will get the clarity. Okay.
Yeah. Okay.
So here, we have one more routing protocol, that is OSPF. Okay. So here OSPF stands for Open Shortest Path
Open
First.
shortest path first.
Okay. So here, what happened? So we have the disadvantage of EIGRP is it only supports Cisco
It
devices, right?
will Cisco
Cisco
device.
devices. But to overcome that disadvantage, we have OSPF coming to the picture. So it supports wide variety of network vendors. Okay, this is the link state protocol. Okay, so it will choose the best path based on the distance. Okay, and here hop count is unlimited. If you between source and destination, n number of distance. Okay, but in case of EIGRP, the default is 100. But if you want to increase, we can increase up to 255. Okay, so classless it is again. So we can use n number of classes, /27, /26, like that. Okay.
Okay.
And here, like we have something called, so to send the routing information between the neighbor routers, it will send hello packets within 10 seconds. Like, like every 10 seconds, it will send a message to other routers saying that, give me your routing information, what you are connected to, something like that it is. Okay.
Okay.
And we have something called, like area 0 and area 1 are. Okay. Suppose consider that, like this is the main network, that is area 0. Okay. So area 0 should be having the backbone routers, and from there we can connect to some multiple networks. So area is nothing but like a divide, separating the large network into smaller networks. That's it, called area. Okay. So at least we need to have one area to configure the OSPF. It means to say. Okay. So here it consider area 0 is the primary one, and whatever the routers which are connected to it, it should be connected to this area 0 network. Okay.
Okay.
So here, the advantages of OSPF is mainly, unlimited hop count and, like a fast convergence with respect to routing information. Okay. So, but though we have many advantages of OSPF, but there is some disadvantage, that is it consumes more CPU resources. Okay.
Okay.
And there are some resources called, like support only equal cost load balancing. Is something like, balancing of traffic load across the redundant links at the equal cost. So we have two links which are connected to it. Okay. Suppose we have router and this router, some routers. Okay. So if you connect it to like multiple things, it will share the load in the uniform way.
Okay.
So like load balancing, we can say. Okay. So that is about like OSPF, and we have one more thing called BGP, right? So BGP is nothing but it's a border gateway protocol. So this is EGP again, exterior gateway protocol. Okay. So here what we are doing. So this is the one autonomous system inside one autonomous system. This is another autonomous system. This is another autonomous system. Okay. So here between inside the network which is in the autonomous system, we are using IGP. Okay. Between the autonomous systems, EGP. That is exterior gateway protocol. Okay. So this exterior gateway protocol is BGP. That is broader gateway protocol. Okay. So like let's go through some small recap. So here we have static route. Okay. Default route. Dynamic route. Okay. Static route is manually configured. Okay. So that by the network administrator. So the disadvantage of static route is if n number of routers we have in the organization, that is very difficult to configure the routes each by every time if you want to log in by manually. Okay. So we have default route coming to the picture. When we are not sure about destination, we discuss, right? Like while we were discussing. So in those cases, we'll use the default route while accessing the internet. Suppose while accessing the internet, you don't know what is the IP address of the destination, right? So in those cases, we'll go with the default route. One more thing, we have dynamic route. So in dynamic route, we have IGP,
protocols, BGP,
IGP. Okay. So in IGP, what we have RIP version 1. So the disadvantage of RIP version 1 is it's a classful. Okay. So that's why we have one more protocol coming to the picture, that is RIP version 2. Okay. So here the disadvantage is limited hop count.
Host. Oh, sorry.
Not hop, host is hop count. Okay. That is 15 hop counts between the source and destination. Okay. So that's why we have one more protocol coming to the picture, that is EIGRP. Okay. So it is developed by Cisco proprietary protocol. It is okay. So here like the limited hop count, it is resolved. It can
100 to
support 100. By default 100 is if we can extend till 255. But the disadvantage is
It is
only
accessible only
supports
with Cisco.
Cisco routers.
Yeah.
Okay. So that's why we have one more protocol coming to the picture, that is OSPF. So it is having unlimited
Unlimited host.
hop count, not host. Okay.
Yeah.
Unlimited hop count, and it is supports for all the vendors of routers.
Variable.
Okay. That is about IGP. What is the disadvantage of IGP here? It supports only inside autonomous system. Okay.
Okay.
But if you want to connect between the autonomous systems, okay, so we won't use IGP. We need to have EGP coming to the picture, that is
BGP.
Exterior Gateway Routing Protocol, that is BGP. Okay. So here in whatever the dynamic routing protocol it is, okay, we will configure the networks which are directly connected. Okay. And other routing information, it will be gathered by using the configuration call, dynamic routing protocol configuration. Okay. That is about dynamic routing protocols. So here we were discussing about the administrative distance, right? Okay. So here, like if you can see, okay, so directly connected network, it is having 0 AD value. Static route, it is 1. And if you remember, we discussed about RIP, right? Either version 1 or
Yes.
version 2. Okay.
Version 2.
So we have AD value is 120 only. And EIGRP we discussed 90 to 150 between 90 to 150, 170. Okay. So something it is. Okay. So here if you have, if you have static route and dynamic route, okay, what it will take? It will be preferred static route only.
Okay.
Why? Because the less value, it is more trusted, right? So it will go with the trusted path. Is it clear? Suppose
Yes.
if you want to reach one destination IP address, okay, so for that we have static route and dynamic route, both are available. Okay, so at the point of time it will prefer the static route only, because the AD value of the static route is less than the dynamic routing protocols. Okay.
Okay.
So it uses that. So this is about dynamic routing protocols, and in next session we'll discuss about different types of WAN connectivity. Okay, so what is WAN, and we'll discuss about what is WAN connectivity. Okay.
Okay.
And then ACL, by that we'll be ending with in 2 or 3 classes we'll end with 3 classes will end with network basics. Then we'll start with the firewall.
Okay.
Yeah.